Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum class. I hope you will find and enjoy good health. This is lecture number 4 of the partial differential equation. In this lecture we will derive the wave equation. We will discuss some basic definitions, and we will also revise the Newton's second law of motion, and we will apply the Newton's second law of motion to derive a mathematical expression for a vibrating string. So before going to details, we will discuss some basic definitions, basic concepts, and basic ideas. Any function y is equal to f of x represents a curve in the xy plane. For example, the y is equal to sine x represent this curve. This is actually the graph of y is equal to sine x. This means that a quantity y which changes with respect to x. If we change the value of x, we will get different value of y. At x is equal to 0.7, the value of y is 0.6. This is the graph of y is equal to cos of x. You can see that the quantity y, which is the distance of the curve from the x-axis, depend on the variable x. So we can say that any function y is equal to f of x represent a curve in two-dimensional shape in a two-dimensional space. Now, what does a function of two variable represent? If we have a function u is equal to f of tx, we often think that this this function represent this function will represent some surface in the three-dimensional space. We will take the example of u is equal to sine t plus cos sine t plus sine x. So this is a quantity u which changes with respect to time and which changes with respect to x also. The graph of this function is shown in this figure. Here u is basically the height of the surface. We see that at different x and at different time t, the height of the surface means u is different. Now the function of two variable means u is equal to f of tx also represent a moving curve in two dimension. For example, consider the function u is equal to sine x into cos x. Then we see that at time t is equal to 0, the function is u is equal to sine x. If we start changing the time, the curve will start moving. So basically this quantity u of xt is equal to sine x into cos t. This represents a moving object in this two-dimensional shape. You can see that the quantity u, which is the height of the curve from the x-axis, changes with respect to time. Similarly, um, we will take another function u of xt is equal to x multiplied by 2 pi minus x divided by t square. So if we see, this function also represent a moving object. Look at this function also. The the moving object related to this function e power minus t into sine x is shown in this animation. Now consider the following setup. uh, a string of length L is flung between two rigid bodies. These are two rigid supports, and between these two supports we have fixed a string whose length is L. Now if we place this string in the coordinate system and displace the string from the equilibrium position, then the string will start oscillation. Now let's look at the like this animation. Suppose we have displaced the string from the equilibrium position to this position, and we release the string from this position. Then what will happen? This string will start oscillation. Now this is also a moving curve. So as discussed earlier, any function of two variable represent a moving curve. Alternatively, for every moving curve, there is a function of two variable. We we note here that the the height of the string at this point at x is equal to L and at x is equal to 0 is fixed, means the these points at these points the string does not move. Okay, so the moving behavior of this curve tells us that there is a function u of xt which describes this motion. In order to find an expression of the function u of xt, we will use some facts. uh, the we will first gather all the known result. We know that the left end of the string is fixed. The height at x is equal to 0 remains 0 for all time t, and the height at x is equal to L remains 0 for all time t. This is the initial displacement of the curve. If this initial displacement is represented by f of x, then we will write u at all values x and at time t is equal to 0 f of x. And if we apply certain force on this string in the upward direction or in the downward direction, then that force may also be considered. That force may be considered as the initial velocity ut, means the derivative of u with respect to time at time t is equal to 0. Assume that is g of x. Now recall some properties from physics. You may know about the tension in strings. The amount of force a string exerts on an object is called tension. For example, if we suspend a mass m from a solid support with the help of a rope, then if we observe that the downward then then it is clear that the downward force on the mass is equivalent to its weight, and the upward force on the mass is the same. That's why the object is at equilibrium position. So it means that the string in this setting exert a force of mg Newton in the upward direction. If the tension in a flexible string is 5 Newton, and if that string is connected to an object and the other end of the string is connected with a rigid support, then this will mean that this string exert a force of 5 Newton on this object in the right direction. Now consider this setup. We have a mass m, and we have connected it with two rigid supports with a string. The tension in this string and the tension in this string is T Newton. This means that this string pulls this object T Newton in the right direction, and this string pulls this object minus T Newton in the left direction. As both these forces are same, therefore this object will be at equilibrium position. Similarly, in the same setup, if the tension in one string is T1 Newton and the tension in the other string is T2 Newton, this means that the red string exerts T1 Newton force on this object in the right direction, and the green string exerts minus T2 Newton force in the left direction. So the total force acting on this object will be minus T2 plus T1. So the object will move either in this direction or either in this direction. For example, if t1 is greater than t2, then the object will move toward the right, and if t2 is greater than t1, then the object will move toward the left. Now consider this setup. If an object is connected with two rigid supports with two different strings, uh, this is the object, and this is connected to this support with us this loose string, and the tension in this string is T2 Newton. This object is also connected with this rigid support with the red string, and the tension in the red string is T1 Newton. Also, the blue string makes an angle theta 1 with the horizontal x-axis, and the red string makes an angle theta 2 with the horizontal x-axis. Now, this setup makes two different kind of forces: the horizontal component of forces and the vertical component of forces. So for this force T1 Newton, the y component can be calculated by T1 sine theta 2. So this component is T1 sine theta 2. Similarly, this component is minus T2 sine theta 1. This is the total, the sum of these two forces is the total y component of the force. Similarly, the total x component of the forces will be minus t2 cos theta 1, which is the x component of minus t2 Newton, and t1 cos theta 2 Newton, which is the x component of t1 Newton force. Okay, so in this setup there are two different kind of forces. One force is the horizontal force, means the y component of force, and this force is equivalent to minus t2 sine theta 1 and t1 sine theta 2. If we know the string, the tension in this string and the tension in this strings and these angles, we can calculate the total downward force by using this relation. Similarly, we can also calculate the total x component of forces in by this relation. Now let's move toward our main problem. Assume that a string of length L is fixed between 2 points at x is equal to 0 and at x is equal to L. Further, assume that the string is flexible. The string is flexible means that if you displace the string or if you stretch the string, then the string restores its shape. The string is homogeneous. This means that the string is made of only one material. The tension in the string is uniform, means at every point of the string the tension is constant. No other forces acts on the string, means we will not consider the gravitational force or any other force. Let u of xt represent the displacement of this string. Consider uh, let let this is the string which is fixed between at x is equal to 0 and x is equal to L, and we have displaced this string to the initial position, this one, which is the red curve. Now consider the portion of the string between 2 point x and x plus delta x, means this portion in the rectangle. So the tension in the string is assumed T. Then the minus T1 Newton force will act on this portion tangent to this curve in this direction, and T Newton force act on this portion tangent to this curve in this direction. So the net force acting on the portion is only the sum of y component of forces. We have assumed that this portion only moves in the upward and downward direction. So the x component of the forces will be of no effect. The only effect is of the y component of forces. So the total force acting on this portion is actually the sum of y component of these two forces. So we will write f is equal to t sine theta 2 minus t sine theta 1. This is the net y component of the forces. We also know that for small values of the angle theta, sine theta and tangent theta becomes equivalent. If theta is small, then sine theta and tangent theta is approximately equivalent. Okay, so we can change sine theta 2 by tangent theta 2 and sine theta 1 by tangent theta 1. So we will find some approximate force equivalent to t tangent theta 2 minus t tangent theta 1. Now the tangent theta 2 is basically the slope of the curve u at point x plus delta x. Tangent theta 2 is the slope of this tangent line, and the slope of the curve at this point and the slope of this tangent is same. So tangent theta 2 can be uh, interchanged by the derivative of this curve at this point. So uh, the quantity tangent theta 2 is the slope of the curve u at point x plus delta x, and tangent theta 1 is the slope of the curve at point x. Therefore, we can write tangent theta 2 is equal to derivative of u with respect to x at this point, and tangent theta 2 theta 1 is the derivative of u with respect to x at this point. Hence, what will be the total force? The total force will be F is equal to T into ux at x plus delta x comma t minus T into ux at xt. Ux means the derivative of u with respect to x. Okay. Now we can also calculate the mass of this small portion. So if we look at the density, so density is actually mass or volume. From that definition, we can calculate mass is equal to rho multiplied by delta x. We also know what acceleration is. The acceleration is basically the second derivative of u with respect to time. So we will note that a means acceleration is equal to u double t of xt. These are all complete ingredients of the Newton's second law of motion. The Newton's second law of motion states that force is equivalent to the product of mass and acceleration. So using the force, the estimate of force is equal to the estimate of mass multiplied by acceleration. So we will get this expression. If we divide this expression by t delta x, we get ux at x plus delta x t minus ux at x t divided by delta x is equal to rho divided by t u double t. Okay. Now if we tend delta x approach to 0, then this quantity will become u double x, means second derivative of u with respect to x, and this expression will become u double x of xt is equal to c multiplied by u double t of xt, where we have generalized the c as a representative of rho over t. So the mathematical expression which satisfy or which describes the motion of that string also satisfy this partial differential equation. Okay, the solution of this, if we solve this PDE, we will get a solution, and that solution will describe the motion of the string. Okay, the solution will also satisfy this condition and this condition, and the solution will also satisfy the initial condition and the initial velocity. This is called the wave equation. Inshallah, in the next class we will we will try to solve this equation. So we will try to solve this equation by separation of variable technique. Okay, take care and Allah Hafiz.